Welcome to our video. Today, we will be exploring the Newton-Raphson's method of numerical methods. So, what is Newton-Raphson's method? It is an open root finding method for nonlinear functions, which means that we pick an initial x value and iteratively solve to approximate the root of our function.
Now, we will apply this method into Microsoft Excel. First, we need to derive the function that we have. As you can see, this is the derivation of the function. Next, we will prepare 4 headers, each titled iteration, x current, fx, and f'(x). The x column is our initial guess of the x value. The fx column is our original function, while the f'(s) is our derived column. Now, we will enter our iteration and the initial guess x value.
For our fx column, be sure to select the x current value cell for all of our inputs to x within our function. This will ensure that our formula works as intended even after we increase the iterations. After that, for our f'(x) column, we repeat the same thing from the fx column, except now we are using the derivative of our function. Moving on, for the next x value, we'll need to use the following formula of the Newton-Raphson's method. The idea is that we use the first order of Taylor series expansion to find where our tangent line crosses the x-axis.
So, as the initial x value guess is replaced with the newly found x term in the next iterations, we can put this in iteration 1's x current value. Now, all we need to do is drag these values. And then, drag this column all the way to our 6th iterations. Thus, we can validate that our answer is not diverging and is showing trends towards similar values. Hence, the root of this function by Newton's method is 1.3247.